Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. And here's the problem for today. You are given that the joint density of random variables x and y is f sub xy of xy equal to x plus y for x between 0 and 1 and y between 0 and 1 and 0 otherwise. Find the variance of x plus y. And here's the solution. So let's just write z for x plus y. This is the random variable we're working with. And x is between 0 and 1 and y is between 0 and 1, and we're adding them so that z is between 0 and 2 with probability 1. Using the concept of convolution, f sub z of z is f sub x plus y of z, and it's the integral from minus infinity to plus infinity of f sub xy of x and z minus x, so that this pair, x and z minus x, if you add them up, you get z. Okay, well that's basically the integral from over the region where x is between 0 and 1 and z minus x is between 0 and 1 of z dz, and that's the integral over the intersection of 0, 1 and z minus 1 to z, because that's the interval where z minus x is between 0 and 1. That basically means x has to be between z minus 1 and z of z dz. Okay. That intersection, when z is between 0 and 1, is equal to the interval from 0 to z, so we have the integral from 0 to z of z dz in that case, and when z is between 1 and 2, that intersection is equal to is the interval from z minus 1 to 1, so this is the integral from z minus 1 to 1 of z dz, and that's equal to z squared when z is between 0 and 1, because that's, with respect to x, it's an integral of a constant z, so we just multiply that constant by the length of the interval from 0 to 1, which is z. So z times z is z squared for z between 0 and 1, and then z times z 2 minus z, which is the length of the interval from z minus 1 to 1, when z is between 1 and 2. Okay, so we end up with z squared for z between 0 and 1, and 2z minus z squared for z between 1 and 2. And therefore, the expected value of z is the integral from 0 to 1 of z times z squared, so z cubed dz, plus the integral from 1 to 2 of z times 2z minus z squared, which is 2z squared minus z cubed dz. And that first integral is easily calculated as it's 1/4 z to the 4th evaluated from 0 to 1, so it's 1/4. And the second one is 2/3 z cubed minus 1/4 z to the 4th evaluated from z equal 1 to z equal to 2, so that this becomes 1/4 plus 16/3 minus 4 minus 2/3 plus 1/4. And therefore, what is 1/4 plus 1/4? It's 1/2. 16/3 minus 2/3 is 14/3 minus 4. We have a common denominator of 6, so 3/6 plus 28/6 minus 24/6, and that's equal to 7/6. And the expected value of z squared is calculated the same way, except the density is multiplied by z squared instead of z. So it's the integral from 0 to 1 of z to the 4th dz, plus the integral from 1 to 2 of z cubed times 2 minus z dz. So that's 1/5 plus the integral from 1 to 2 of 2z cubed minus z to the 4th dz. And that's 1/5 plus 2/4 z to the 4th minus 1/5 z to the 5th, evaluated from z equal 1 to z equal to 2. And that's 1/5 plus 8 minus 32 over 5 minus 1/2 plus 1/5. And that ends up being 3/2. And then the variance of z is the second moment of z minus the mean of z squared. So it's 3/2 minus 49 over 36. 54 over 36 minus 49 over 36, and that's 5 over 36, and that's answer A. Please remember this is copyrighted material. The problem itself was written by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.